Slide shows a general architecture of a hypothetical real-time embedded system where a microprocessor with RTOS. So RTOS, as in the previous class we have discussed, it is real-time operating system, handles control and other interface tasks, while the DSP performs high-speed signal processing. The communication is done through a system bus and dual port memory, ensuring efficient data transfer without strict hard deadlines. So let us try to explore the major blocks and their functions that has been depicted in this figure. First one is the user interface. Over here we can see the user interface. So the user interface is used to connect to the microcontroller, which is, as we can see, a MUC here stands for microcontroller. So it handles user inputs such as keyboard, then touchscreen, display, or it can have non-critical timing like ideal for soft real-time system. This is the microcontroller, so which performs very critical operations. So it is acting as a main system controller. It has certain responsibilities. It performs system initialization, device configuration, communication control, user interaction, and it communicates with the other components through the system bus. As we can see that the system bus is spread over all the blocks and the microcontroller can communicate with the other blocks in the architecture in the system through the system bus. Then we have got real-time operating system, where the real-time operating system, as we can see in this figure, that there are certain blocks which has been represented by dash lines and some are with solid lines. So dash line indicates that they are actually code or they are software, and the solid line indicates that they are hardware blocks. So we will be talking briefly about the real-time operating system. It runs on the microcontroller. It manages multiple software tasks such as controller process, which controls system operation, user interface process. It handles display and user interfaces. It ensures task scheduling, inter-process communication and responsiveness. In soft real time, missing deadline degrades the performance but doesn't crash the system overall. So next is the ASIC. As you can see, this hard block is ASIC, which is actually full form is application specific integrated circuit. So it is in hardware. This hardware actually have dedicated specific function, and since here it is hardware, so it improves speed and efficiency. It offloads repetitive or time critical functions from the microcontroller. Then we have system bus. So as previously discussed, the system bus provides the communication backbone of the system. It connects, as you can see, the microcontroller. Then there is a DSP processor. Then memory is there. You can see memory is there. Then codec is there. Codec stands for coding and decoding. So with the help of the system bus, each block can interact with each other in the system. Then we have got digital signal processors. Here we can, in this particular architectural view, there are two DSP processors. These DSP processors are specialized processor for real-time operation, and the specialized processor for real-time operation. And here they can be processing audio signals, they can be processing video signals, they can be doing image processing related work. And the DSP assembly code, they run on the DSP processors. These DSP assembly codes are specific to the processors, and they are written to optimize the signal processing work for the embedded system. Thereafter we can see the dual port memory. Now this dual port memory is basically a shared memory, because it will be having two access points. Both signal DSP processors can access them through different ports, so they can perform independently read and write operation without any interference. And they can perform fast data exchange, simultaneous read or write operation. So that's how they provide expedite the operation, and the desired objective or desired time constraints can be achieved. Then we have a codec block. So this codec block, as I have told already, it is combination of coder and decoder. So this performs encoding as well as decoding operations. So it is basically used for converting analog signal to digital signal, and also vice versa. This is mostly used in audio systems, communication systems, and it interfaces directly with the DSP. So with this we come to the conclusion of this part of the lecture, and we will continue our discussion in the next lecture. Thank you.